Morning, gang. The other day I did that interview for Behind the Bots, and he asked, hey, about the rain. And I said, it never rains in the desert. Basically for 4 days straight. 3 o'clock this morning, pouring down rain. 4 o'clock this morning, pouring down rain. 5 o'clock this morning, pouring down rain. 6 o'clock this morning, pouring down rain. 7 o'clock this morning, it's starting to slack up a little bit, but as you can see, it is not pretty out there. One of my new subscribers asked for me to explain the electrical system that I use out here. So I figured instead of showing you more Dancing Girls from Second Life, what we'll do is go through a real quick explanation in the most, and I don't want to say simple because I'm not trying to be simple, but basic, the most basic terms of what it takes to run an off-grid power system. We're going to discuss solar versus turbine, MPPT versus PWM. It sounds a little complex right now, but I'm going to break it down into the simplest, most basic terms I can think of. If you're interested in running an off-grid electric system, stick around. It's going to be a good one today. This is a diagram of an off-grid electrical system at its most basic level. First, you need some way to collect power, whether that's solar panels or turbine. Then you have some way to store the power, normally 12-volt DC batteries. Then you have the load or draw that comes straight from the batteries. That's the power you're actually using. This is a complete system and is all you need as long as you're only running 12-volt loads. The next step is an inverter. This is a unit that changes your electrical power from 12-volt DC to 110 or 220-volt AC. Once you install an inverter, you'll be able to run most 110-volt appliances such as radios. You don't want to use things that cause heat, such as heaters or coffee pots. They draw a lot of electricity. What we're going to cover first is the charge controller. There are a couple different types. There's many different brands. There's many different styles. What I'm going to do is go through the 3 major styles and tell you which one's best for the system you want to install. Not every system requires a charge controller. If you have one small 50-watt panel on your boat, charging one small battery just to run your radio, you don't need a charge controller. One panel, one battery, that's all you need. A lot to digest, and I don't want to overload anyone. I was an electrician. That was one of my very first jobs as an electrician. I was a journeyman electrician. I've worked in explosion-proof situations, garbage bag factories, an industrial electrician, a residential electrician. So I know electricity. The charge controller's job is to stop the power from the sun to the battery when the battery gets full. Because when you overcharge a battery, it shortens the life of the battery. It makes it not as good a battery. So you don't want to hook a solar panel straight up to a battery, positive to positive, negative to negative, and just let it charge up, because it's going to kill your battery in a very short amount of time. It's not going to last long at all. The charge controller stops that flow of energy and interrupts it when the battery's full, and it lets the power go through when the battery is not full. It's a very simple thing. However, this is where things get interesting. There are a couple different types of charge controllers. You have a very simple on-off controller. This is the most basic. They probably $35 to $50 for it, and it's a very simple one for like a boat. If you have one panel and one battery, and you just need something to click on and off, and you're not living off of it, the on-off charger, it's a great little unit, but it's very, very basic. If you wanted a little more flexibility, you need the next step up. This is a PWM. Pulse width modulation. PWM controller is a little bit better. It costs a little bit more, but that's because it's a little bit better. What the on-off switch does is it just turns off the power when the battery is full. A PWM notices that the battery is full and turns the power down to a lower level. It lets it continue though on a slow trickle charge. So instead of just running down to the low point where the on and off switch would kick back on, what the PWM does is it keeps a little bit of power going through there so your battery doesn't go down to that. It's a much better system. It works better. It's more economical. It gives you more power. It's just a little bit better. Pulse width modulation. Now, if you want to have windmills, solar wind turbines, or if you're really going all and you want to live full-time off the grid and you want the most power you can get, you want MPPT, maximum point projection tracking. It's what it does is you consider it like a water faucet. When the power is full, it turns the power down and it's slowly ramping, and it turns that power into more current. I'm not going to get into current voltage draw and all that stuff because I don't want to get into that right now. But the MPPT, what it does is it turns excess voltage into current, which is better to charge your batteries with. You can run higher voltages with MPPT. If you want a grid tie system, it must be MPPT. You can't use anything else. MPPT is the best. It's a relatively new technology. Be careful. Don't go out and buy a $100 MPPT controller and expect it to be better than your PWM. It's not going to be. If you spend $300 on an MPPT controller, now you're getting into the range of the good ones. Do your research on the controller creator. Who built it? Do they have good reviews? Do they have a good reputation? Don't get a fly-by-night cheap MPPT controller. In the end, it's going to cost you more. They're expensive, but they're worth it because they give you so much more. You can use a simple on-off. They're usually $30, $35. PWM is the next step up. That's the most common right now. So most people have, and they run 100 or more depending on how much draw you have. MPPT is the best. This is insane. It's like I come from Florida, and they say in Florida, if you don't like the weather, stick around 5 minutes and it'll change. That's what's going on out here today. 1 minute the sun is shining and it's beautiful, but then 2 minutes later, this entire thing will roll over the mountain and just inundate. And man, this wind is insane. I'm going back inside. I have to do the water jug thing. Got to do it every day. If I don't do that, my food goes bad. So I'm going back inside. See ya. We're going to talk about inverters for a minute. I get my inverters from Harbor Freight, okay? There's nothing wrong with the little Harbor Freight inverters. Some people hate them, some people love them. I could care less either way. They're convenient, they're inexpensive. If one blows out, I can take it back to Harbor Freight and get another one. It's no big deal. I use multiple small inverters instead of one large one. Now there's two types of inverters. We're going to go real quick through this. If you're not running a computer or some high-end electronics, you don't need a square sine wave inverter. Just a regular inverter will work for you. However, if you're using computers, high-end electronics, some of my battery chargers require a pure clean sine wave, and that inverter costs a good bit more, almost double what the equivalent that's non-pure. So if they say sine wave, pure sine wave, clean sine wave, this type of thing, that means it's putting out a nice clean form of 110 volt electricity, 220, whatever you're using, and that's what you need for a computer. If you're not using a computer, you don't need that fancy expensive one. If you're not using large equipment, you don't need a giant mega 7,000 watt inverter. However, what I'm doing with my 4 little units here, each one has its own inverter, each one has its own battery pack. They're isolated, but they're connected. I have switches in each one. I can turn each one off of the system. I can cut it out of the system with the other ones. I can let it back into the system with the other ones. 2 of the huts have solar panels on them. 1 of them has a wind turbine. Actually, 3 have solar panels now. I got some up on the shop. And the other one has a turbine and 2 solar panels. That's the one with the hybrid controller. They all have their own battery pack. Those battery packs are joined together. They're joined together in parallel, so everything is 12 volts. So what we're going to do real quick is explain the difference between parallel and series, because it's kind of important if you're going to live off a battery pack. To use the water hose analogy for series versus parallel wiring, a series water hose connection would be, you have the faucet, you put on the hose, you run the hose out, then you put a battery here. Obviously you wouldn't put a battery in a hose, but it's an analogy. You put a battery here, hook the hose to one end of the battery, to the other side of the battery you hook another hose. And you take that hose down and you put another battery down there and you hook, you keep going. You put battery in the middle, hose, battery, hose, and the whole thing runs as a series through the system. Every time you pick up another battery, you pick up the voltage from that battery. So if this is a 6 volt, you have 6 volts, 12 volts, on and on down the line. Every time you pick up another battery, you will pick up the voltage from that battery. To use the hose analogy for parallel would be to put a T on the faucet and then run 2 hoses off. I wasn't happy with the explanation I gave for parallel. It wasn't clear enough. Man, it's getting bad out here. If you take a faucet, you put a T on the faucet, then you run 2 hoses off. One of those hoses goes to the negative terminal of that battery that you're putting at the end of the hose. The other hose goes to the positive terminal of that battery. So you have 2 hoses, one goes to positive, one goes to negative. Now you take 2 more hoses, positive and negative, run them straight to another battery, the negative to the negative, the positive to the positive. In parallel, you're running negative, 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 positive, 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 positive. One after the other in line, but they're in parallel. In series, you run negative to positive, negative to positive, negative to positive. That makes it a series connection. Parallel is negative, 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 positive, positive, right down 2 lines. Series is 1 line, negative to positive, negative to positive, negative to positive. That's what makes it jump up every single connection, because you're going through instead of past. Better? Yeah, I like that one. That's the difference between parallel and series. The reason real quick why a wind turbine requires MPPT. When you have a wind turbine spinning, unless it has a brake where it can stop, it will constantly be pushing out power. Now a solar panel is pushing out power anytime there's sun, but it's an electronic thing. It can be shut off with not an issue. It's like a water faucet. When you turn off the faucet at the house, it's in those metal pipes. Those metal pipes don't care about the back pressure. When you turn the hose off way out at the end, the hose gets pressurized because all that rubber is not really made to hold all that pressure all the time like the metal is. So this is basically the same thing with these two systems. The wind turbine has so much pressure and power that it will blow up the rubber hose. What an MPPT controller does is it lets you bypass that power. It puts the excess, what's called a shunt, not the shunt from Robot Wars. It shunts it off to another place. What I did with my last big system, I had 2 turbines, 3 panels. I had a 55-gallon stainless steel water drum on its side. I put a water heating element in it, and I used my shunt controller, my MPPT controller, hooked it up to the hot water heater, and anytime I had too much power, I made hot water. I mean, it's a very simple system. Too much power, run it off into a heating element and make hot water with it. Some people use air heaters, some people use light bulbs. There's a million things you can use to get rid of that extra power. Some people use more batteries so they don't have to use it. That's the best way to go. But if you have a wind turbine and it doesn't have a brake and can't shut off, you need someplace to shunt your extra power. And that's often the MPPT is the only controller that will do that. A PWM controller will not shunt power. You cannot run a turbine through a PWM controller. You have to have MPPT. The new turbines have a 3-phase inductive controller, and they do amazing things with the electrons and stuff. They're buzzing around inside, and you don't need the MPPT shunt with these newer systems. They're relatively inexpensive. Mine is one of those. 3 wires go from the turbine into that, and it goes straight from there to the 12-volt battery. It puts out 12 volts. It puts it out automatically. I don't have to worry about anything on it. However, I have them run through an MPPT controller because I have it tied in with solar panels. I have a hybrid system, so I use a hybrid controller. The hybrid controller is specifically designed to match wind turbines and solar panels together, let you record, track, and do everything you want to do to see what's doing what, balances all your loads, and charges up the batteries. So the hybrid controller, what I use, is the best way to go. I'm going to have to cut it short because I'm running out of power here because I haven't had any sun in 4 days. So I'm kind of low on power because I don't have enough batteries. Still need to save enough to edit this thing together into a video tonight. So that's it for now. We'll have to touch on batteries and things in the next video. I did really enjoy this though. You know, if you have more questions about the things I'm using out here, or how I live and things, I enjoy it. Ask your questions in the comments down there. I hope you liked the video. I appreciate you watching. If you have any questions, ask away. I'll be glad to answer them for you. Next time, we'll get into batteries. Ciao.